Happy Friday. My name is Tom Cramer. I'm the Chief Technology Strategist at Stanford University Libraries. And joining me today in a presentation will be James Simon, also from the Stanford University Libraries, to talk about the Deepen, the Digital Preservation Network, and a report not on the need for Deepen or on the development of Deepen, but specifically on the technology and the services that a group of a distributed team has been working on since last fall. And joining us in the room today are Ladd Hansen, who's roughly speaking, the Director of Library Technology at UT, and Steve Morales, who is the Director of Deepen. And so when James and I will be doing a presentation, and then we'll leave plenty of time for discussion towards the end, which may involve, hopefully, many people from throughout the room. So, what is Deepen? I know James Hilton and Steve have actually done an impressive job of running through the need for Deepen and its structure, including at previous CNI meetings. So I won't go into great detail on this, but I'll give like the 30-second James Hilton accelerated talk. So Deepen is 57 member organizations at this point who are working cooperatively on investing in large-scale, long-term digital preservation. Deepen also includes a number of technical staff and systems at 5 major preservation repositories, plus working groups with experts in succession rights, business planning, communications, and data services that are collaboratively working to build a digital preservation backbone for the Academy, run by the Academy for the future of the Academy. That was it. James can do that in an hour. I hope James watches this video later. So the initial Deepen technical partners are listed on the slide. So we have the Academic Preservation Trust, Chronopolis, HathiTrust, the Stanford Digital Repository, and the University of Texas Data Repository. Duraspace is also participating as we call them the pseudonode. They're a contributing partner, but they're not a host of any of the content. And specifically, the work that we're here to talk about today has come out of weekly and more frequent conversations that the group on the slide represented has been, or the names on the slide have been pursuing since last October. So it was just in terms of the rough time frame, about last March and April, there was a big hullabaloo, the convening of Deepen. Around May or June, there were enough members and a membership organization had formed, and starting in July, members of the what ended up being a rump executive team for Deepen met at Stanford in July to try to figure out what it would actually mean to establish these nodes and the technical framework to support Deepen. In August, technical team members convened for a 2-day meeting in Chicago, and in October, we actually began a series of weekly phone calls interspersed with ad hoc meetings from people working in a variety of elements. The most important area that we were first working on was actually defining what the system would do, was taking the high-level concepts and the need for digital preservation network and trying to translate that into something that could be built and services that could be offered that would be of value to the members of the organization as well as to the Academy going forward. And after about 3 months of discussion, we came up with both a high-level description of what the Deepen, what the network would actually do, some of the benefits, some high-level specifications, and then we began work on specification and development of individual components. And so moving from the vision to something that's actionable actually did require a fair amount of work, but we've reduced it to kind of 5 key principles at this point. So first, Deepen establishes a network of heterogeneous, interoperable, trustworthy preservation repositories. We call these nodes, and we'll be using that terminology throughout the rest of this talk. Deepen replicates that content across the network to multiple nodes. Deepen enables the restoration of content to any node in the event of data loss, corruption, or disaster. Deepen also ensures the ongoing preservation of digital information from depositors in the event that any individual node or any original depositor divests himself from the content, ceases to operate, or for some reason can no longer maintain access to that content over the long term for the Academy. And then finally, Deepen critical function is it provides the option to technically and legally brighten content preserved in the network over time. Again, the notion here is that depositors will come and go, nodes will come and go, and Deepen is forever. It provides a framework where individual nodes can enter and they can leave, but the content persists and the promise of access to that content persists. In terms of benefits, we think that there are 6 major benefits to the network as envisioned. The first one is resilience, which is, James has also talked about this as the archive of archives. So no matter how good your archive is, no matter how many local copies you have, there's always still a risk that it is still one concern and one operation. And if that archive fails for reasons that might not be technical, could be financial, it could be organizational, it could be political, the content that's in that archive would be at risk. And Deepen is a insurance against that. 2 is succession, whereas archives come and go and depositors come and go, the ability to actually carry the content forward with rights to access the content, not just the technical option, but with rights to be able to brighten and use it in new context is a critical benefit. 3 is economies of scale. We're all working on, or many of us, the majority of those that attend CNI are working on some kind of local preservation system, but many of us are not at the petabyte level. With the amalgamated content of the current nodes and the interest in deposit from the distributed members of Deepen, we're talking about multi-petabyte scale, and the ability to leverage some of those economies of scale by aggregating content into a few larger nodes promises to be more economical over time. And 4th is efficiency, is for anyone who's set up a local preservation repository or tried to broker agreements, reciprocal deposit agreements, or reciprocal preservation agreements, there's actually a tremendous amount of overhead just in the legal, the business, the contractual, and the trust framework. We think Deepen establishes a network and a framework that actually, regardless of the technical underpinnings, provides value in enabling content or preservation repositories to exchange content with each other. 5 is extensibility. We anticipate that the services and the framework that Deepen, or the services and the architecture, the membership and the content that's currently envisioned for Deepen will be very different in 10 years and will be very different in 50 years. By bringing together a network, I think an unrivaled network in North America with the scale and the scope that James and Stephen managed to assemble, we actually have the ability to channel those efforts into new efforts, much the way as James Hilton has talked about, as Internet 2 started with a backbone and has now moved up to Net Plus services. And then finally is security, in terms of being able to safeguard content in a secure environment, secure against corruption, vandalism, or leakage is a critical benefit for those who are concerned with content that may be more than open access, which is a large part of the use cases that we're concerned with. So some of the critical assumptions and definitions, and these have come up over the course of some of the conversations with various members and some of the other discussion forums where Deepen has come up. Right now, the assumption is that all content will enter Deepen by deposit into one of the Deepen nodes. This provides a number of benefits. One of the primary ones is manageability. Over time, there have been discussions that this is something that technically doesn't need to persist. We might think about something that's more like a BitTorrent model or reciprocal exchange. But in terms of setting up the technical, the legal, the contractual, and the successioning framework, we think there's value in bringing some order and consistency into the way content enters and who is taking stewardship for the content in the network. We call the point of entry for any given piece of content the first node. So that's how it comes in. Any other node in the network that receives copies of that content is known as a replicating node. What we imagine is that Deepen members and content depositors will work directly with an individual node to bring content into the network. So HathiTrust members, for example, will work with HathiTrust to get their content into HathiTrust and through HathiTrust into Deepen. And we imagine further that as part of every individual contract with individual nodes, there will be some standard Deepen language and standard Deepen agreements that will provide for a level of services and a level of guarantee, as well as the options to access content in the future that go beyond that individual contract, so beyond HathiTrust or Stanford or Chronopolis, for example. The service levels will reflect some kind of standard Deepen offering. So by putting content into the network, you're acknowledging that there will be some sort of right and access to get to that content for academia under the appropriate conditions and trigger events in the future. The first nodes may also choose to augment those services with different services that they provide. For example, HathiTrust again, with the rich set of bibliographic delivery services that they've developed. And then finally, a critical assumption is that as the content comes in, content in replicating nodes is explicitly and by design dark. These will not be access points for the content. So HathiTrust content that comes into Deepen will not also be served up via Chronopolis or served up via Stanford or AP Trust or University of Texas. Unless and until there is an appropriate trigger, Hathi chooses to divest itself or is divested of its content, and the Academy feels like, well, we've got this petabyte of books, we need to make sure that there's ongoing access. So Deepen provides that framework and that option, but the assumption is that the content depositors and the first nodes actually control access to that content while both are still viable and until those trigger events have been met. One of the critical assumptions, as I mentioned earlier, is that the nodes will change and the membership in the nodes will change. By design, they will change. New nodes will come. Some of the existing nodes will undoubtedly leave the network. One of the critical functions of Deepen is to be able to redistribute and balance content across the network as nodes enter and leave. Deepen will also provide a large-scale network of archives that enable the opportunity to brighten content into the future. Deepen will not mandate how this is done. Thinking about the scale and the diversity of content and depositors that are coming in, this is by design not a curation environment. This is by design not a place where individuals, curators, or even institutions are looking at, on a continuous basis, the content to make sure that it is accessible. And it will be up to the depositors, to the first nodes, and to their designated communities to work with Deepen and the content that's deposited into Deepen to make sure that it could survive any sort of event which might make the content inaccessible from the original depositor site if they're choosing to serve it, or the first node site if there's an agreement that the first node could serve it. So that is, basically, Deepen gives the option to brighten content. We do not expect that option to be cheap or to be easy, but it will be there. So if Hathi, for example, were to blink out, well, we usually would talk about Stanford falling into the ocean. If Stanford were to blink out in an instant on all of the digital medieval manuscripts that we hosted and that were distributed through the network were in other Deepen nodes, we would not expect that HathiTrust or, Chronopolis might be gone at the same time Stanford was. The University of Texas would be able to brighten that content with a flip of a switch. They would, however, have all of the information that they would need to go through an exercise to restore that content and bring it up into an appropriate access environment for that community, maybe with different kinds of access services than Stanford originally provided. So one of the items that the technical team has been working on is to try to take these high-level statements of intent and vision and benefit and actually come up with relatively straightforward set of specifications. If you look at the bottom of this slide, you'll see on the DuraSpace wiki there's a Deepen space, and there is a link at the top level to some of the specifications that have been documented so far. So I think there are about 20 currently on the slide. So just to give you some of the highlights, Deepen will make multiple copies of content from a first node to replicating nodes. Not controversial, good to write down. Deepen will repair or replace any replicated content at any node when corruption is detected. Deepen will assure the security of replicated content during transmission so that no content is lost, corrupted, or exposed. And Deepen will be able to support the introduction or exit / cessation of a Deepen node by redistributing content at scale. And so when you start getting up to multiple petabytes or beyond, and you're looking at new nodes entering and leaving, you are looking at a large-scale data migration project. And so these are some of the factors that we're at least documenting right now and trying to work into the early design. So just a couple of scenarios. The picture's worth 1,000 words. So here's the most basic one. You have a depositor on the bottom left who is putting content into a Deepen node. And so in this case, that's the first node. The second step is that content then replicates to the dark preservation areas of two replicating nodes. So straightforward. Here's one demonstrating the restoration of content. So content has already come in from the content. Scenario 1 has already happened. Scenario 2, the purple arrows indicate a continuous process of audit. An event happens at the first node where they discover that they don't have a known good copy of the content as originally deposited. That content is restored with the green arrow from the repository in the top left. And then the first node can go on to continue to provide hosting services for the original depositor or retrieval services. So getting into a more interesting scenario is you don't have just a minor fault, you have an epic failure, as my kids say. And the first node actually goes away or ceases to operate or can no longer fulfill its function as an archive. In this case, because the content's been replicated, one of the other nodes in the network takes the bagged and archived the dark files, brightens them, and is then able to return them to the original depositor. And then 4, over the very long term, and we think this will be sadly more typical than atypical, is the first node may have ceased to function, the original depositor may no longer be around, and yet a new Deepen member here on the bottom right may say there was good content that was originally deposited in those series of transactions on scenario 1. We would like to be able to brighten that. They could then, through some process of bidding or arbitration or negotiation, actually get access to those files from the replicating node, which would brighten them and then deliver them in a new environment to the Deepen members or to this specific Deepen member. So again, these are the options to work out. As I think many of you will be saying, well, this raises a lot of very interesting policy and service and contractual questions. Those, in fact, are the architecture is co-evolving with those discussions and those designs as they're happening. But something roughly like this that we know that the architecture needs to be able to support. So, in terms of examining the top-level architecture, a slightly different view. By design, and James will talk a little bit more about this, we are trying to keep either no center or very little technical center to Deepen because that adds overhead and that adds a single point of failure. And so what we're looking at is, again, content coming in and in the top corner from a contributor to a given node, and then each node is maintaining a common set of infrastructure or a common set of components that satisfy the same functions in an environment of network exchange. And so to drill down just a little bit further, we've identified 7 or 8 critical components that every function or every node will fulfill. So the first one is obviously the actual archive or the repository that's storing the content and providing fundamental preservation services. Well, I'm going to go through each, but you can read these up on the slides. The first one is the archive or the repository itself, which is taking care of the bits, is making sure that they're preserved, that they're secure, and that ongoing preservation actions are being applied. The second one is really the central nervous system of Deepen, which is the way that the different nodes coordinate with each other and communicate, signal to each other what content they have, when it's available for replication, what the results of audits may have been. And so this is a federated messaging system. The team is actually devoted, the technical team, after identifying kind of the high-level services and the components, has spent the bulk of its time trying to understand what this messaging environment will look like, because this is going to be the thing that stitches the network together. This actually is the interstitial linking of the different nodes. Each node will also have a registry. We'll have a full copy of the registry of content that's stored across the network. And that's for keeping track of inventory, keeping track of events, and just an overall record of the content and the events within the network. There will be a series of standard transfer mechanisms to get content from one node to another. We've started off with a KISS principle, so keep it simple. And we're looking at evaluating both HTTPS and rsync. In the future, we may get into more advanced or more data-intensive transfer methods like grid systems. But for now, We're looking to stand up the most basic and simple systems. There will also be a standard content packaging design and content packaging mechanism. So regardless of how people store their content internally, regardless of what preservation actions they take, if they want to exchange content across the network, it will be through a standard Deepen package. And then finally, security encryption. As part of being a Deepen node and as part of transmitting content over the wire and storing it, each repository will have to meet a certain level of security and internal security and transfer protocols that set a bar. One of the interesting things about the project is we've been looking at encryption at rest, not just encryption over transmission. We think that there's a fundamental requirement that Deepen be able to support this. Because we know that some content will not come into a distributed network of preservation repositories unless the depositors or the first node can guarantee that it's actually encrypted at rest remotely. And so this leads to some interesting design considerations about how do you encrypt it, but then through key escrow and other mechanisms, ensure that the content is still accessible in the event that the first node or the depositor goes away. So that's a high-level overview of the network itself. What the network is going to be doing, some of its technical componentry. I should add that 2 additional components that we know will exist but we haven't spec'd out yet will be a logging environment and a logging system, as well as a reporting system. Critical functionality for Deepen the network will be able to give reports to members and across the nodes about what content has been ingested, what's been transferred, whose content is where. And so those are not currently on the diagram, but we know that those will be coming. So now my colleague James is going to go a little bit more deeply into some of the architectural design questions and specifically the messaging.
Okay, so the architectural overview. So Tom actually did a really good job of sort of giving even sort of a little more than sort of the marketing view of what Deepen is doing. So I'm going to talk about sort of some of the architectural sort of decisions and some of the activities that we're undergoing right now, especially around messaging and some of the basic components. So part of our architectural premise was that sort of each of the institution has its own proven repository, and that's actually key. That means that each of the institutions can do all of the necessary things to preserve the data at rest and the bits. We all have audit functions. We all understand what fixity is, and that's actually really important. If we're starting from scratch, then we'd actually have to have really long discussions about what it means to preserve the bits. The other design considerations were that the nodes are distributed and that we're not going to have a tightly coupled model, meaning that we won't do remote procedure calls between nodes. We won't share code. We will actually have independent implementations of the functions and services that Deepen will provide. And this actually allows Deepen to have sort of problems at an individual node, but the rest of the nodes can continue on and run. Okay, but we do need to have sort of standards around sort of the interactions and the protocols that we use, and we do have to have this distributed infrastructure. So then, as you see this picture on the right, this is what the Federation looks like. And one of the things that Tom mentioned is we have that concept of the first node, which sort of controls its own content. But we also have all of the other nodes, the replicating nodes, and each node in the Federation can act as a first node. And each node in the Federation can act as a replicating node. Okay, so now Deepen has this sort of hierarchy of content where the first node owns the content and provides access to its access communities and does its preservation activities. And then the replicating nodes for that content also have, the second tier in that the data model. And that means that the first node can start activities such as do an audit check against content that is stored at multiple nodes and confirm that the content is correct within the network. So, and finally, within the Federation, it's also the federation level and at the first node that we need to keep track of any of the preservation agreements, and we can actually use Deepen itself to preserve those agreements over time. And over time, we know that we're going to have to change various algorithms, like the fixity algorithms. I think SHA-256 there's now a SHA-3, so that's the new algorithm. We know that SHA-256 will probably run out of steam in about 2037 at the very latest, and that we're going to have to change the fixity. Each of the nodes will be responsible for logging and reporting, and again, these reports, by the way, they can either come from a central Deepen entity, or they probably, and this is what we're thinking about in design, they should be able to be generated at each individual node as well. So the components in the technical architecture include, sort of, as Tom mentioned, the nerve structure, which is the messaging infrastructure, and this is a common infrastructural component. So we're going to use message brokers at each of the sites, and we're going to federate those brokers. And we're trying to avoid sort of common technology at each of the sites, but this is one of those technologies that, for now, we're choosing a common technology. Now, when we reevaluate what's going on in Deepen in sort of the second phase of the implementation, we may look at sort of still using AMQP, which is the underlying message protocol, but using a non-federated or a disparate broker model. So each node will have their own broker for handling messages, and they'll just communicate using the base protocols. The second component that's really important is the registry. And actually, the registry is critical to the operation, and it is the most preserved item in Deepen, if you will, in that all of the nodes will have the same, well, they'll have a registry, which will be a separate implementation, but they'll have the same information in each of the registries. And we'll keep that information in sync. And it's going to track the objects within the federation, the copies. We're looking at a versioning system, so the version of the object, the sort of top-level rights, not necessarily the rights within the object itself, but the rights that allow succession and operation within Deepen. And so the registry becomes sort of, if the messaging system is the nerves, then the registry is the brains of the system. Okay, so we're looking at the transfer systems, and right now, as Tom said, we're keeping it simple. We're looking at HTTPS, so we're using a REST model, and we're also looking at rsync, but we've also had suggestions around grid FTP, and in the future, we may be looking at really parallel, so grid FTP is a parallel transfer model. We may be transferring terabyte sizes of objects. We're also looking at, and we're having discussions around a private PKI, so that's public key infrastructure, so that we can keep the transport layers secure. And we're looking at how we might, so we've had discussions recently about how we might accomplish this. And again, this is sort of making it a little more secure than sort of the public key infrastructures that are available today, but using the same principles. Tom already mentioned logging and reporting. Again, it's real important, and there are ways to do it. In 1 second, I'll mention that. Okay, so other components that might be sort of common, so we've already, as Tom pointed out, we have sort of a transfer area, and the transfer area is really an idea. Okay, so it's a mechanism for where we put content, but it's going to be implemented separately at each site. So Deepen from a node perspective is really a set of protocols and messages that tell the members or the nodes to do things. And the transfer area is sort of a conceptual model for where we'll put content temporarily before it's ingested into the repository at that node. Okay, and then one of the other sort of key components that, or key ideas within is that we will use Deepen itself to preserve administrative objects. And those objects, for example, the framework agreements that Deepen provides to the nodes for We can preserve those objects, and we can preserve versions of those objects as well. So over time, it's really important that if we have a succession event or any replication activities, that we be able to track those agreements over time, all the way back to the beginning. So the provenance of the agreements will be tracked within Deepen itself. The second was sort of both the versioning or the brightening information. That brightening information actually may change over time for the objects, even though the objects themselves may not change as we get better technology. So it's important to preserve that information. And if we use encryption, we probably won't store keys within Deepen itself. What we'll store and preserve are the references to the escrow of those keys. And again, that has to tie back to the legal agreements for how escrow is transferred if there's a successioning event. Okay, so now I'll focus a little bit on messaging. So as we've said, it uses sort of messaging, but the messaging is what we call in-band, which means there's a lot of communications going back and forth, and it's really to control sort of what's going on in the replication, the services, and sort of the activities between the nodes. All of the real work, so if we do copies or audit, will actually happen out of band with just the communication happening within the message itself. So we wouldn't want, for example, to use the messaging infrastructure to transfer a terabyte of information. It would be slow and it would clog any kind of messaging. So I already mentioned AMQP, which actually stands for Advanced Messaging Queuing Protocol, and right now we're using RabbitMQ, which is a pretty nice broker, and it supports federation easily, so that was the reason for doing it. Again, this is sort of the first prototype, this is the first prototype, and we'll actually get to a production level, and at which point we're going to reevaluate sort of the broker and sort of the messaging that we're doing. Okay, and so then sort of maybe diving a little too deep is that we're going to be using a queuing structure that sort of specific queues, which we named queues, which are topic queues, and broadcast messages. Okay. And so if you were a Rabbit fan, you would look at this and you'd know exactly what this is. And this is what a federation looks like at a node. This is just as an illustration that we're actually doing it. So we did this a long time ago, and we have the federation up and running. So basically, I'm the node, the little circle on the left, and when I send things, it will federate that message across the whole Deepen infrastructure. Okay, but a more simpler view of that is this, where if I want to broadcast a message from SDR, and so everybody has three letters except Hathi and Chronopolis, and I shorten them, so hopefully they won't take offense at that. So if I want to send a message and I want to broadcast a message, it really just looks like this. So that complicated diagram before really boils down to this, is I send a message from SDR and it's broadcast to all of the nodes, and all of the nodes will pick up the message and do something with it. Okay, and if the broker goes down, so if SDR loses its broker, we can actually, since this is federation, I can go to TDR's or Chronopolis's broker, and I can still send messages out. So there's high availability built into the model. Again, if you have a nerve center, you'd like it to be up. So then the other kind of message that we do, and so broadcast messages really are useful for initiating, are you available for replication, or here's an error message, or here's a reporting message that goes out to all of the nodes, which can then capture that. But if we're in a transactional model, so once I've done a broadcast, then I actually want to talk point to point or node to node around sort of that activity. So a direct message looks like this. So SDR to Hathi. And it's between two nodes, and it's private. Okay, so each node in the message, so once I broadcast, will actually send back a response which tells us where to continue the transaction. Okay, so the broker federation still applies. I can use any of the brokers within sort of the 5 nodes to transfer even point-to-point messages. So then each of these messages, so the messages aren't sort of one-off messages, it's actually a sequence of messages to do a specific task, right? So we call those message control flows, and then within the message control flow there's a protocol that overlays the control flow so that we can do what we want in a sort of secure and reliable way, right? And so examples of the control flows are sort of the replication request, so I broadcast out that request, and then I get responses back that say who's available for doing the request. Once I've actually transferred the data, then I need to create an item in the registry, and then broadcast that out, an update for the registry to all of the nodes so that they can record that information about objects. I also have registry synchronized, so we'd actually like the registries to be as synchronized as possible, but in a distributed model, that's actually not possible. So we have to use the model rather than a database model, sort of the traditional database model. We use the model called eventual consistency. Okay, and then also the other part of the message flows will be sort of recovery of the digital object, recovery of registry entry, etc. And then the fixity audit flows. So some of those will be broadcast around fixity, some of them will be point-to-point or direct messages, so that the first node can actually check fixity at replicating nodes. So messaging isn't workflow. So I think most of the digital repositories have either fixed, or I shouldn't say fixed, they have workflow systems in place. I know we do at SDR, and the workflow defines how sort of ingest occurs, and from ingest to accessioning to sort of delivery to access and delivery to sort of the preservation area of the archive. But we're using a messaging model to actually control the work that's done at Deepen, and we're not using a shared workflow engine, which would be bad. Actually, that would be a single point of failure, and it wouldn't be good. So it really means that each of the nodes will have to keep track of the state of the messages and keep track of the state of the transaction that's occurring. And if we think about it in a messaging environment like this, all of the messages and the work will be happening all at once. So there's a lot going on. So when I broadcast out for a replication request, I'm going to get back maybe 4 different answers. Some of them will say, yes, I'm available, and some will say, no, I'm not. Hopefully I'll get the minimum required. And so we need to keep track of the state. And that's something that we're well aware of, and we're all going to implement it. We may implement it differently, but my guess is we'll all implement it in a very similar way. Okay. So if I look at sort of the simple view of the replication flow, this is actually one of the design diagrams that I use to sort of, it's a sequence diagram, is that this shows, you know, what happens from the start. So on the start it's SDR, pointing out to node X, and then going all the way down to the end where I acknowledge that the copy has happened. And during that happening, you know, we need to do things like the content is checked for fixity. We've already pretty much decided that we're going to use sort of a single fixity check within the Deepen nodes, so that we can have a common algorithm and sort of make it more efficient. And again, the state of the transaction is managed by each of the nodes. Okay, so some of the issues that happened when you do a replication are that the first node has to track the successful replication of all of the nodes. So if the first node needs 3 copies out there, it has to track each of those 3 nodes, and then has to decide when to send out the broadcast to all of the nodes to the registry. Okay, so we're almost there, we're not quite there, but the basic algorithm that we're looking at is that we will, the first node will wait, have a quorum of successful copies, and then broadcast out the registry. Now, if let's say the quorum is 3 and only 2 respond, we can still send out the registry update and then just go back and reinitialize the copied occur and then do an update to the registry later. So the beauty of sort of not having a workflow system is that we can continue to do work, right? And we can recover from sort of a failure in the network and still have a security around the copying of the nodes. So if I was going to look at a more complete copy of sort of, and this is the eye chart, if I was going to look at a more sort of complete view of how replication is going to happen that included sort of logging and reporting and also registry update, it would look more like this. Okay, where the first node is the one that's in red, and then the replicating node is to the right of the red node on top. And there's a lot of stuff going on, and including sort of all of the housekeeping and the registry updates over time. And this is a simplified view of the kind of protocols that we're looking at. Okay, so now I'll focus a little bit on the registry. And it's interesting, even within our own working group, we talk about the registry as an entity or, sort of an implemented thing. But in fact, within the Deepen model, the registry is a series of messages. So all of the communication handles as messages, and then it's up to each site to update their registry as they see fit. So some sites may be using Oracle, some may be using MySQL, some may be using MongoDB, or so NoSQL models for the registry. But we'll all implement the registry sort of as we see fit. Okay, and then we have the registry and the kind of messages that it has have to be able to create a registry entry, read a registry entry, update a registry entry, right? And delete is actually a special case because this is an archive of archives, so delete actually won't be part of the normal operations but it'll more likely be part of the operations that require sort of a person to agree to, because we don't want accidental deletes. We don't want replacements without which is a replacement is a copy and a delete, right? So that would sort of violate the principle of where Deepen is. So again, the registry is replicated across all of the Deepen nodes, and it is the most preserved item. Okay, so this is a prop, by the way, is that this is sort of one of the initial registry, and this is only half of the message that, for a registry creation message. And the point here is that sort of the body of the message needs enough information sort of to capture what, where the objects came from, where the digital object came from, who the owner is, where are the replicant copies, what date it was created, possibly, and we're not certain because we're having discussions around this, what rights information is necessary, and versioning and so on. Now, since we don't want to reinvent the world, one of the other components that's actually critical to Deepen is how do we package the digital objects and then transport them between each of the nodes. So we've decided that we'll probably use, we are going to use a sort of a Deepen Baggett structure, so it'll be Baggett. It'll follow the Baggett spec, and we're going to standardize the bag, right? Now, we've actually been talking about once we decide on what's in the bag itself, and this is like those basic items, and there'll probably be a one-to-one mapping for the bag and the registry entries as well, is that we'll then sort of lock that down and create a profile for the bag that we can then validate the bags as they're transferred back and forth. And that will be protected within Deepen because we'll create a Deepen object, an administrative object that will hold those profiles. And so we'll be able to, over time, check the bags as they were entered into Deepen for validity. Okay, I had a whole bunch of slides on versioning, and then we realized that we're still having a lot of discussions around versioning. But we already know that a lot of the objects within Deepen will need versioning, okay, and they'll benefit from versioning, and now it's just a matter of sort of coming up with the exact mechanism. Okay, so we know this sort of, we're looking at sort of a differential versioning model, which means that we won't duplicate content unless we have to. So obviously, if there's a format migration that goes on within an object and it's a versioned object, then we'll have to duplicate content. But the goal of the versioning of a versioning system within Deepen will be allow us to go back to the initial entries into Deepen and get that original content. Okay, and as I've already mentioned that administrative objects actually will benefit a lot from versioning. Right? The more we do this, the more we know. And Tom actually, this is my last slide, so Tom actually already talked about encryption, and this is what, part of the reason for doing encryption is that we're required to. The other part might also include, well, if I encrypt content because I'm required to, I also need to preserve the keys, and the best way to preserve keys is to use a third-party escrow. And in this case, I'm showing the encrypted copy is A prime, or with the double slashes through it, and I have one escrow. But if I have 3 copies within Deepen, I'll need 3 escrow keys because I want to preserve the keys in an escrow as well as I preserve the content itself. And all of the escrow has to be tied back to the Deepen framework agreements and the Deepen agreement, and the agreements with the first node. So if there's a succession event, I need to transfer the agreements over to the new node so that they can access the content as encrypted. And this is a little bit tricky. The encryption is, and any of these things are a little tricky if you think in the long term, because we're going to have to change algorithms, we're going to have to change mechanisms for encryption and fixity over time. And that's part of what Deepen will do, and this is where sort of economies of scale and sort of collaboration really works, because now we can all agree as a community on what the right method for doing this is over the long term.
Thank you very much.